What is regression? Regression is a technique to understand the relationship between variables. It helps predict the value of one variable output, continuous number usually based on one or more other variables, inputs. What is that linear regression, and how is it different from other regression techniques? Linear regression predicts an output by fitting a straight line to the data. It's simpler compared to other techniques like logistic regression, which is used for categorical outputs, or polynomial regression, which handles non-linear data. Why is linear regression called linear? It's called linear because it assumes a straight line relationship between the input variables and the output. The predicted output changes linearly with changes in the inputs. What are the key assumptions of linear regression? The main assumptions airy 1, a linear relationship exists between inputs and output. Point 2 to residuals, errors are normally distributed. 30, errors have constant variance and therefore inputs are not highly correlated. On Hugging Face that, how do you check if the assumptions of linear regression are satisfied? You can use scatter plots to check for linearity, histograms or QQ plots for normality, residual plots for constant variance, and correlation matrices or VIF scores for multicollinearity. What are the different types of linear regression? There are two main types. Is one point simple linear regression, where one input predicts the output, and two multiple linear regression, where multiple inputs are used to predict the output. What is the role of the cost function in linear regression? The cost function measures how far the predicted values are from the actual values. Linear regression minimizes this error, usually using a method like least squares. How does gradient descent work in linear regression? Gradient descent adjusts the coefficients of the model step by step to minimize the cost function. It keeps changing the values until the error is as small as possible. What are the advantages and disadvantages of linear regression? Advantages: it's simple, interpretable, and works well for linearly related data. Disadvantages: it struggles with non-linear data, outliers, and highly correlated inputs. What are some alternatives to linear regression for predictive modeling? Alternatives include decision trees, random forests, support vector machines, SVM, neural networks, and non-linear regression techniques like polynomial regression. What is multicollinearity and how does it affect linear regression? Multicollinearity occurs when input variables are highly correlated. It makes it hard to determine the individual effect of each variable and can lead to unstable predictions. How can you detect and fix multicollinearity in linear regression? You can detect it using correlation matrices or VF, variance inflation factor. To fix it, you can remove redundant variables, combine them, or use regularization techniques. What is the difference between simple and multiple linear regression? Simple linear regression uses one input variable to predict the output, while multiple linear regression uses two or more input variables for prediction. What are outliers and how do they affect linear regression models? Outliers are data points that are very different from the rest. They can skew the regression line, leading to poor predictions and less reliable results. How can you handle outliers in linear regression? spaces that you can handle outliers by removing them, transforming the data, or using robust regression methods that are less affected by extreme values. What are residuals in linear regression and why are they important? Residuals are the differences between the actual and predicted values. Analyzing them helps check model assumptions and identify areas where the model may not be performing well. What is the R squared metric and how is it used in linear regression? R squared measures how much of the variation in the output is explained by the input variables. A higher R squared means the model fits the data better. What is adjusted R squared and why is it preferred over R squared? Adjusted R squared adjusts for the number of inputs in the model, unlike R squared, which can increase with more variables even if they aren't useful. It's better for comparing models. Space that can. What is the difference between a p-value and a confidence interval in linear regression? A p-value shows whether a variable significantly affects the output, while a confidence interval provides a range of likely values for a coefficient. Both are used to assess the model. What else spaces can? What are some common metrics to evaluate the performance of a regression model? Common metrics include mean squared error Messier, root mean squared error MMSE, mean absolute error MA, and R squared. These measure how well the model predicts the output. Can linear regression be used for classification purposes? Linear regression isn't ideal for classification because it predicts continuous values. Logistic regression or classification specific algorithms like decision trees or SVM are better suited for such tasks. How would you choose between linear regression and more complex models? I'll start with linear regression for its simplicity and interpretability. If it fails to capture the patterns G due to non-linearity or complex relationships, consider more advanced models like decision trees, neural networks, or ensemble methods. What is the role of cross-validation in linear regression? Cross-validation splits the data into training and validation sets to ensure the model generalizes well to new data. It helps detect overfitting and aids in hyperparameter tuning, such as choosing regularization parameters. In what scenarios would you avoid using linear regression? Avoid linear regression when at 1 the relationship between variables is non-linear, and 2 multicollinearity exists, Monty 3 dataset has many outliers, or 4 the output variable is categorical rather than continuous. What is the difference between linear regression and logistic regression? Linear regression predicts continuous outputs and assumes a linear relationship between inputs and outputs. Logistic regression, on the other hand, space that can predicts probabilities for classification tasks and uses a sigmoid function to map outputs between 0 and 1. How do you handle multivariate linear regression when the number of features is very large? For datasets with many features, use dimensionality reduction CG, PCA to reduce complexity, feature selection to identify important inputs, or regularization methods, lasso or regent to prevent overfitting. What is a dummy variable and why is it used in linear regression? A dummy variable is a binary variable 0 or 1 used to represent categories in categorical data. It enables linear regression to include non-numeric variables in the model. For example, male could be coded as 0 and female as 1. Publican, how do you interpret the intercept term in linear regression? The intercept represents the predicted value of the output when all input variables 0 as the baseline output value, assuming no influence from the input variables. Now, what is the significance of coefficients in linear regression? That can coefficients indicate how much the output changes for a 1 unit change in an input variable, holding all other inputs constant. They show the strength and direction of the relationship between each input and the output. What are the limitations of linear regression? Linear regression assumes a linear relationship, making it unsuitable for non-linear data. It's sensitive to outliers and multicollinearity, and it may not perform when the data set is high dimensional or has irrelevant features. What there is the difference between OLS ordinary least squares and gradient descent? OLS calculates the best fit line directly by minimizing the sum of squared errors, making it faster for small datasets. Gradient descent iteratively adjusts coefficients to minimize errors, making it suitable for larger datasets or when analytical solutions are computationally expensive. How can you test for and address heteroscedasticity in linear regression? You can test for heteroscedasticity using residual plots or statistical tests like the Bruce-Pagan test. To address it, use variable transformation CG, log weighted regression, or robust standard errors. What is heteroscedasticity and how does it affect linear regression? Heteroscedasticity occurs when the variance of residuals is not constant across all levels of inputs. It violates a key assumption of linear regression, leading to unreliable coefficient estimates and predictions. How does linear regression perform on non-linear datasets? Linear regression performs poorly on non-linear datasets as it assumes a straight line relationship between inputs and output. Non-linear regression, polynomial regression, or tree-based methods are better options for such data. Running phase spaces can. How do categorical variables affect linear regression and how can be handled? Linear regression can directly use categorical variables. They need to be converted into numeric formats like dummy variables or one-hot encoding to be included in the model. What is that, Ken? What is the role of feature scaling in linear regression? Feature scaling ensures all inputs are on the same scale, preventing variables with larger scales from dominating the model. It's especially important when using regularization or distance-based techniques. What is elastic net and when would you use it? Elastic net combines L1 lasso and L2 regularization to balance feature selection and coefficient shrinkage. It's useful when features are highly correlated, where lasso alone may struggle. What is space that the difference between L1 lasso and L2 region regularization? LL1 lasso reduces some coefficients to 0, effectively selecting features, while L2 ridge shrinks coefficients but doesn't eliminate them. Use lasso for feature selection and ridge when all features are important. What is regularization and how is it applied to linear regression? Regularization prevents overfitting by adding a penalty to the cost function based on the size of the coefficients. L11 lasso and L2 ridge are common regularization methods used in linear regression. What is overfitting in linear regression and how can it be avoided? Overfitting happens when the model learns the noise in the training data instead of the pattern, leading to poor generalization. It can be avoided by reducing features, using cross-validation, or applying regularization. What is the difference between MSE, RMSE, and MAE? When would you use each? MSE mean squared error, penalizes large errors more and is useful for detecting large deviations. RMSE root means squared error is MSE's square root and gives errors in the same units as the output. My mean absolute error treats all errors equally and is less sensitive to large deviations. Use MAE for robustness and RMSE when outliers are important.